So picking off from where we left off, we now have velocity versus time graphs and how to interpret them. So they basically follow the same format as position versus time graphs. Like if we look over here on the y-axis, it's velocity in meters over seconds, and then on the x-axis, it's time in seconds. And the way you read this is at a specific time, you can get the velocity. But there are two more things that you can get from velocity versus time graphs, which is displacement and acceleration. Regarding acceleration, we're going to go more in depth about it in our video where we tell you how to convert in between position, velocity, and acceleration time graphs. And if you're just watching this video and haven't checked out the position versus time graph video, here's a really good website to visualize the difference between these three different graphs, and we should hopefully have it as a link in the description or in the comments, something like that. Either way, so our first point is, how do we get displacement from velocity versus time graphs? So displacement in this regard is just going to be the area under the curve. And why does that work out? Well, if you think about the area, it's typically base times height, right? And then in this case, base is basically time, and then our height is basically velocity. So if you multiply velocity times time, the units that you get is meters, which is the displacement. And then area above the curve is going to be positive, area under the curve is negative. So from here to here, we're going to make an imaginary scale. Let's just say that every single little segment is 1. So in this case, we're going to have these two added together minus whatever that is, and that's going to get you your displacement, and that works out for any point on the graph. And then regarding acceleration is just going to be the slope of the line. And why does that work out? Well, the slope is going to be y over x, rise over run. And then if we look at the units again, y is velocity in meters over seconds, and then x is t in seconds. So if we divide those two, you get meters over seconds squared. And we'll go more in depth as to how to tell the acceleration in that video that I mentioned earlier. Anyway, see you guys next time.